And I guess the last slide here is I wanted to summarize what you'll get out of Science Olympiad events, for build events at least, and their connections to engineering. They're recurring themes that, one, you should make your device adjustable or build with adjustability in mind. Remember gravity vehicle? We needed to make sure the cart will stop at any point between 9 and 12 meters. So you can't just hard code or build it so that it stops at exactly one point. There has to be some sort of freedom to adjust it. And this freedom to adjust is very important in real life cases where either your device has to handle a range of different scenarios, or you're not sure if the setting that you have now will be the best. You need to adjust it to make sure it works a bit better. So build with adjustability in mind. The next is testing and documentation. For those of you who have done a little bit of coding, you'll know that this is quite valuable. Right here, I've gotten a picture of some sort of function, and for people who are not familiar with computer science, functions are things that they're kind of like math functions, except you tell a computer to do the math for you. You have some sort of inputs, and this function gives you an output. Now, if you didn't see these two lines, these two bright pink lines, that this function would load process edges from a file, blah, blah, you would be guessing as to what this does. Like, you have to decipher what the heck all of this abracadabra means. But here, you look at this and you understand, okay, I know what this thing does. And it saves people time, and it helps you write more organized code, and it also transfers to hardware as well. So documentation is critical for making sure that other people can understand what you're doing. And maybe this other person can be you in the future. So it might be useful for you as well. Oh dear, let's come back to the side. Yes, so in hardware, documentation is also important because you won't get something right on the first try. The first time you build something, it will fail, it will break, or it won't work at all. You need to keep track of the improvements you make and the testing you do to make sure that you don't repeat your previous mistakes. And writing things down as you go and taking lots of pictures and giving yourself progress updates will help save you time and organize yourself to the path of success. And even a little bit of genuine effort here goes a long way. And finally, we have reducing variance and sources of error. I talked to you about variance in the previous slide. Now, it really boils down to this, or this picture here, which you might have seen in science class. If you have a poor measurement, your points will be randomly scattered around. They will be all over the place, in simple terms. That's no good for competition. We want the Science Olympiad, the whole point is to have precisely working devices. So the projectile has to reach the target. The gravity vehicle needs to stop at a certain point. And you need to make some improvement to make sure that the points that you're getting, the results that you're getting are closer to the desired one. So that can look in several ways. An improvement, you can either increase your precision, which means that your device always, let's say your catapult will always launch into this one corner here. So all of them land here. It's consistent with itself, but it's not where you want it to be. You want it to be at the bullseye. The next step is bringing it closer to actually reaching the bullseye. And typically, reaching the bullseye is easier than making them all consistent. So this happens all the time in real life. The way we have computers working, airplanes working, everything is making sure that we have consistent and predictable results as we expect. And these events in Science Olympiad, they teach you how and why this is important. And they also give you some insight into the physics, the electrical engineering, the mechanical engineering, all of that, aerospace, and that goes in and is behind all of these cool little games that you could play. So 3 life lessons, and I still use them. They're very useful, even for me and for engineers that have decades of experience. Except on the top of my head, these are my favorite, or the ones I could remember. The list can be longer, and your list could be different as well. Thank you for watching. I hope that by now, you're also excited for the build events. If you're interested in learning more specifics and details about each of the events, take a look at the build event workshops, which I will upload and link in the description soon. In these workshops, I plan to teach you the fundamentals about each event that are necessary to be successful at the competition. I wish you the best for your future endeavors.